So we got a graph of f of x there, and we're asked to sketch the graph of y equals 4, f of negative 0.5 x. So this is in function notation, and if we're going from left and the right, the first number we run into is the 4. What is that 4 going to do? Is it going to be a one that's going to move it up and down by adding and subtracting, or multiply? It's going to multiply it. So when it's outside, so you're right that it's going to affect the y, but if we're moving things up and down, we're going to see that with adding and subtracting numbers at the end. And here, with the 4 in front multiplied by this, we're going to multiply our y by 4. And then the next number we run into is a negative a half. That's inside the function, so it's going to affect the x. We have to do the reciprocal. And it's going to multiply the x by negative 2. We can do that all in one step. If we were describing it, if we were describing in words everything that's going to happen here, it's going to get stretched vertically by a factor of 4. It's going to get reflected over the y-axis, because the x is what's going to have a negative. And it's also going to be stretched horizontally by a factor of 2. So if we had to describe it in words, we'd have to describe all three of those things. Now, as far as what's going to happen to this graph, if we look at our original graph, we have a point here, negative 2, 0. And if you wanted a couple other points, maybe you took this one here, 2, 2, to get a sense of what's going to happen. Draw our arrows to see where that's going to change. We can write out what we need to do. We need to do y by 4 and x by negative 2. A very easy mistake to do when doing this is to multiply the x-coordinate by 4 and the y-coordinate by negative 2 and just mix them up. So just be careful. Take your time. We want to multiply the y by 4, so that's going to stay 0. X by negative 2, this is going to become positive 4. Same thing here. The y by 4 is going to change that to an 8. The x by negative 2 is going to change that to negative 4. So when graphing this, we're going to have the point 4, 0, and we're going to have negative 4, 8, which is currently off of my graph. So if I wanted to find another point on my graph, I could look at my original graph and say, is there another point that looks easy to write down? Negative 1 and 1. I could do the transformations to that point as well. The x by negative 2, we'll take that point to 2. The y by 4, we'll take that point to 4. And 2, 4 does match up on my graph. Now we have 3 points. And we have to make a decision how we're going to draw this graph. Some things that are going to help us. This was the starting point of our red graph. Where did that point go? Negative 2, 0 went there. So we know that that has to be the starting point of the graph that we're going to draw. If we think about what's happened, this one's been stretched vertically, then flipped over the y. Can you see that once it gets flipped over the y, the curve is going to start going in that direction instead? And then it's also been stretched horizontally. So we see that the graph that we end up drawing has the same shape as our original graph, but it's been stretched and it's not completely the same. The negative sign. So that negative, if we think back to section 3.2 where we did the reflections, if a negative is inside the function, which it is, then it's affecting the x. And if you think about your x-coordinate turning to a negative, that's going to flip it over the y-axis. As far as doing the math to the specific point, you don't have to do the reflection and the stretch separate. You can do them all at once. So when I multiply x by -2, it automatically does the flip and the stretch at the same time. Again, it says state the domain and range of each function. So we'll start with our red one. I'm going to use interval notation. Its smallest value is -2 and continues forever. Range, the smallest value is 0 and continues forever. And then on our blue graph, now we have no smallest value, but we have a largest value at 4. And for our range, it's still 0 to infinity. Seven, 9, and 10 are questions that we can do for this, but what I'm going to do is I'm going to call this part A, and I'm going to add to this question a part B and a part C. So for part B, I want you to tell me what is the explicit equation for f of x. So that's a good question. So what that means is, can you recognize the red graph, because that was f of x, as a specific type of graph? Is it a line? Is it a parabola? Is it a square root? Is it a cubic? What type of graph is it? It's a square root. And then something's happened because it's not the square root function right in its original place. So when we're asking for an explicit equation, we're saying, what is the actual equation for that graph? Because using function notation is just sort of, well, it's not a cop-out, but it's like, I don't know what this is, I'll call it f of x, and then we can do our work with it without ever saying what it actually is. So I want you to look at that red graph. What is the equation of that red graph? It's a square root graph. What's happened to that square root graph? It's been moved to the left, so how we would show that? Square root of x plus 2. Okay. Not too bad. Now we're going to practice our function notation. We're going to write the explicit equation for y equals 4, -0.5 x. In other words, the blue one. What would the equation of the blue one be? Well, f of x was our red equation. That's right here above, square root of x plus 2. What does this mean in function notation? This says there's a 4 out in front. So we will have a 4 out in front. And in function notation, if this up here is f of x, what we're doing now is instead of having an x inside the function, we have -0.5x. So that means wherever there was an x, we're going to have to replace it with a -0.5x, and then we still would have that plus 2 inside the square root. So that would be the equation 7, 9, and 10.